Chemistry, the pH of a solution is defined by pH equals negative log H plus. So they can give you any type of formulas they want, right? Ones where they're partially filled in, completely filled in, or absolutely no formulas at all. So we're going through the ones with formulas. Where H plus is the hydrogen ion concentration expressed in moles per liter. Determine the pH of a solution to the nearest 10. Very important. We're looking for the pH. Here is 10. If the hydrogen ion concentration is 3.4 times 10 to the negative 4 moles per liter. So pH equals negative log that 3.4 times 10 to the negative 4. Everyone type that into a calculator. To the nearest tenth, what are we getting?
3.5.
Yeah, negative 3.5. It's just 3.5, not negative. Yeah, 3.5.
Oh, because it's negative 40 exponential.
Yeah.
Oh.
And this one says, a patient gave a urine sample which was found to have a pH of 5.7. What was the hydrogen ion concentration? So now we're given pH. So we do 5.7 minus log, sorry, equals negative log 3.0 H plus. So remember, this is the key thing with logs. If we don't know what's beside a log, so if the variable is beside the log, or the variable is in the base of a log, we cannot solve it as a log, actually. We have to first convert it to exponential, then solve it. Okay? So, repeating this. If the variable is beside the log, or the variable is in the base of the log, we cannot solve it unless we convert to exponential first. Okay? And when we have exponential and the variables in the exponent, we have to convert to a log to get it down. Right? Okay. What is the base of my log? 10. Now I have 1, 2, 3, 4 pieces of information. I can't convert unless I have 3. So what do I need to do? Move that negative 1 over. How do I move it? Yeah, divide it because it's currently being multiplied. So I divide by negative 1. And I get negative 5.7 equals log base 10 of H plus. And then how do I get that H plus out? Remember, I have to convert to exponential, correct? That's how I get that H plus out. So remember, if you have the variable beside the log or the variable in the base of the log, you have to convert to exponential. So what's the base of my log? 10. What's the exponent going to be? Negative 5.7 equals H plus. And then this one says scientific notation to one decimal place. So put 10 to the power of negative 5.7 in your calculator. 2 decimal 0 is 1.99. 2 decimal 0 times 10 to the negative moles per liter. .99 rounds to 2.0, right? Okay, then we're going to flip over. Try this one out. Go. So, I said 40%. P is in percentage. So we do 40 equals 100. 1/2 x over 5,730. The variable is stuck in the exponent, correct? The only way I can solve that is converting it to a log. I currently can't convert it to a log. Remember I told you if you have an initial and a final, the very first thing you're always going to have to do is divide them out, correct? Make sure your phones are in your backpacks. We're going to divide by 100. Phones are not allowed out. We get 2/5 equals 1/2 to the x over 5,730. All right. What do we do? Convert it to a log. It's the only way we can get the exponent to come down. So we get log base what? 1/2, because the base of my exponent becomes the base of my log. So I get log 1/2. What goes beside it? 2/5, because what's friends doesn't stay friends. And it equals x over 5,730. How do I get rid of the 5,730 that is divided? Multiply. Everyone's typing it in? Okay, and that is years. That's a lot of years. When we write a sentence and we say it takes 7,575 years for it to produce 40%. Yeah. Yeah.
Where does the 5,730 go when you're typing in the log equation?
You can do the log and multiply it, or you can multiply it and then do the log. Because you have the log actual button,
Yeah.
you can go 5,730 and then press the log button.
And you don't have to put like a times or anything?
You can though, but you could just do the log first and then times it by that as well. Regressions! Woo! Exact same steps as before, but instead of picking 4, 5, or 6, we're going to pick 9 or 0. Because 9 and 0 are logs and exponential regressions. Okay? So, example 1. Simone, a medical research scientist, is investigating, it should say, a new bacterial culture which could help strengthen a person's immune system. She isolates 50 cells and records the growth of the number of cells over a period of 5 hours. Her results are shown in the table below. Remember what your calculator is doing, it's taking that data and it's making a stat plot of it, and then it's making a line of best fit for whatever regression you pick, right? Remember exponential graphs, we talked about them? They go up and go up, exponential graphs. So we're going to get an exponential graph out of this. All right, so let's first just plot it. We're going to do the stat plot. So 0 and 50, 1 and 75, 2 and 169, 3 and 253, and 4, 3, what did I do? Something's off. 2 and 112. I skipped one. 2 and 112, sorry. 3 and 169. 4 and 253. So it's growing faster, correct? It's exponential growth. And 5 and 380. So it starts growing slowly and then all of a sudden really fast, right? Exponential growth means we grow quick. Okay, we can sketch it. What we can also do now is go put it into our tables. So go into the y equals and clear it. Make sure you have nothing in your y equals. Then you're going to go put it into your lists. So stat edit. Clear your lists. Don't delete your lists. Once you have it in your list, you're going to calculate an exponential regression. You guys go down your list, see if you can find something that looks like exponential regression. Make sure you're following along with your calculators because you are the only one who writes your exam, not me. Stat Calc, which one has exponentials on it? Which number do you think? 0. Now it wants us to determine the exponential equation. So here it has y equals a times b to the x, right? That's how it's written. Like it tells you how to write it out. That is a fancy and a not fancy way of writing a b to the x. And I always like putting my b in brackets because the x is only to the b. Okay? So if we want to write it in that form, I'm going to get y equals, say I say to the nearest 10th, I'm going to get 49.9, 1.5 to the x. Can I use a rounded decimal in my y equals? If I round before my answer, am I going to have problems? Yes. Am I allowed to round before my answer? No. If ever you're like, I rounded, and then you just keep going, just put an X through your question. Be like, I'm wrong. That's what's going to happen. Okay? We don't want that. All right. So remember, how do we get it into our y equals? We go y equals bars, down to statistics, over to equation, enter. And you should have that whole equation in your y equals. Everyone check and make sure you do. Yep. So does everyone get the equation to show up in your y equals? Then in order to graph it properly, we have to go to our window and make it fit this data. So my window starts at 0 and it goes to about 5. I always at least double it. So I'm going to go to 10. 0 to 10 for my x's. My y's, I'm going to start at 0 because bacteria. It starts at 50, so it doesn't matter. And then it's going to grow. So it has 380. I'm going to do 1,000 because I like doubling it. Go to your edit list. I guarantee you have a problem. Wrong number in there. 0, 50, 175, 2 and 112, 3 and 169, 4 and 2. Okay, press graph. You should be able to see your graph in front of you. Remember, if you ever get errors, it's often your window's too small. All right. Now, we have to decide, did they give us x or give us y in the next question? The next question says, determine the value at 20 hours. I need to decide if they gave me x or y. So I go to my table and I look at my x. X is number of hours. Y is number of bacteria. They want 20 hours. Did they give me x or y? X is hours, so they gave me x. So x equals 20. Then what do? Second trace value. Everyone's doing this. Second trace value. Pick up your calculators. Second trace value 20. We're double processing. Oh my goodness, I get an error. Why do I get an error? My x max is 10. I need my x max to be 20. The second trace value 20 after you change your x max to be bigger. Can't see what you don't want it. So we have a substantially large population of bacteria here. 166,903 bacteria.
Why would you put it in?
Now here it says, how many hours to the nearest tenth of an hour will it take for there to be at nearest tenth of an hour, 1 decimal place, at least 1,000 bacteria. So what people put is 1,001. No, you put in 1,000 and then you round up your time. That's what that means. For at least 1,000 means I find what 1,000 is and then I round up my time because no matter what it'll be up, right? Because if I round down I won't have at least 1,000, I'll have a little less. So That is bacteria. That means they gave me y2 is 1,000. So I need to make my y max be bigger than 1,000. Mine is 1,000. I'm going to make it be a little bigger just so I can see the line. So I'm going to make it be 1,200. And then my y2, I put in 1,000. So I do second trace 5, enter, enter, enter. And I get 7.386. If I round it to 7, or I round it to 7, I'd be completely wrong because nearest 10. If I round it to 7.3, I would be wrong because I'd have not 1,000. So even if my decimal was like this, 7.3333333, pretend that's what the actual decimal was, I would still have to do 7.4. Because if I round to 7.3, I won't have at least 1,000, I'll have under. Correct? And you can check your answer. If you go second trace value 7.3, you won't get 1,000 bacteria. You'll get less. Okay? So if it needs at least something, you have to round up. No matter what. This one you would luck out because it rounds to 7.4 anyways appropriately. 7.4 hours. This isn't real. I just was. Okay, and flip over. This one is lawn. Y1, Y2, go. And then we'll talk about which button. I kind of gave you a hint at the beginning of class. There's also a sign up there that only gives you options. A lot of people will pick logistics. Happens every year. Logistics is not logarithms. It's actually the natural lawn that we need. So you guys are going to pick 0. And we'll talk about it in a second. So calculate 0. Stat, calc, 0. Numbers, and my 0 is exponential, sorry, 9. I don't know why I said 0. 9. That's an oopsie. 9 is ln reg. Now, I just want to explain something. So put your calculators down, put your pencils down, everything. I want all the ears. Okay. When I give you like log of x, you guys tell me, oh, that's base 10. I can put a 10 there, correct? If they give you ln of x, just so you know, it's the same as log base e of x. Okay? So even though I know this doesn't look like a log, it is. Ln reg is just log base e. You guys don't know what e is because we don't use e a lot until like university and stuff like that. But you know how you guys just know pi is 3.14159, blah, 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 blah. We even have pi days. People memorize hundreds of digits of pi. Because pi is a number that you guys use in circumference and area of circles and stuff like that. So it's a number that makes sense to you. Well, e is just like pi. It's a non-terminating, non-repeating decimal that's used a lot in life, just not until now. Okay? It's 2.7181, blah, 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 blah. That's what e is. Okay? So whenever we do regressions, we're always going to pick ln reg, not logistics. So many people are picking logistics. Logistics is not logs. It's logistics. Okay. So when this comes up on my calculator, it gives me the form y equals a plus b ln x. It's ln x. Do you see that? And then it tells me what a and b are. On my screen, it tells me that. It says use integer values for a and b. Integer values means not decimals. So, for a, I have 8,067. Plus b, I have negative 8,266 ln x. Do I need to put this plus negative thing going on in there? Will they do that? No, the negative will trump the positive. And this one exists. Okay? Now, we're going to go to our y equals, make sure that it's in there. So go to your y equals and do var statistics over to equation, enter. Make sure you put it into your y equals. Does everyone have it in their y equals? After I get into my y equals, what do I need to do? Change my window. So I'm going to go from 0 to 100 because it's percent x. And then y, I'm going to go from 0 to, I don't know, 10,000. I'm going to make it be 80,000. I don't want to change my windows. Then I press graph, and I see a line that goes downwards because it looks like it's stopping. This is your graph. It looks like it's stopping here. It just pixelates and it gets so close to the y-axis that it looks like it's only drawing like this. Trust me, this is still going up here as well. It just, your calculator, if you go to your table of values, you'll see the y's keep getting bigger. But on your calculator, it kind of stops because it gets so close to pixelating. I don't know, it just doesn't draw it. Logs are the only ones that it like halts drawing for some unknown reason, even though there is still more graph. So don't fall to that. All right. So here we have a bone fragment with the carved image of a mammoth was discovered in the southern U.S. states of Florida in June 2011. All right. Florida in June 2011. If the carbon dating test indicated that approximately 20.3% of carbon-14 was left, estimates the age of the bone to the nearest 1,000 years. All right. So they gave us x. X equals 20.3%. How do we do that? We go second, trace, value, 20.3. Now the answer is 13,182.071 years. They want to the nearest 1,000 years. Now normally, people read that as thousandths, so they think they've rounded correctly. It says thousands. So I would look, here's my thousands. 13, one less than it, or to the right of it is a 1. So approximately how many years would it be? 13,000 years. I haven't seen them make you round to thousands, but it doesn't hurt to practice it. If the skeleton of bison is about 10,000 years old, what percentage to the nearest whole number of carbon-14 should paleontologists find remaining in the bones that they were found? So now we got y, right? So our y2 is 10,000. If our y max is not bigger than 10,000, we ain't seeing it. Boom. Second, trace, 5, enter, 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 and we get 30. 29.8, what do they want it to the nearest whole number? So 30%. Okay, makes sense? Okay, we're going to look at example 3. Example 3 wants an exponential regression. So which number are we picking? 0, which is x reg. Okay. 4 wants an exponential. Typo, but what is it? Exponential. Just oopsie. So we need number 0, x reg. 5, 0, x reg. 6, what is this? Come on. Okay? Those have to be done for tomorrow.